The universe as we know it now began as a tremendously hot, tiny and dense singularity that expanded some 13.8 billion years ago. The universe is everything from the largest galaxies to the very existence of space-time and life. Since then it hasn't stopped expanding, but what if it did? We previously believed the universe to be unchanging before Edwin Hubble's observation of the expansion of the universe in the 1920s. Hubble Space Telescope data from several years later confirmed that the expansion of the universe was accelerating. The universe is getting bigger every day, and what we understand now is that the amount it's getting bigger is increasing every day. Astrophysicists were completely unprepared for this. They thought the expansion would actually slow down as a result of gravity. They proposed that a force is accelerating the universe's expansion in order to explain the discovery. However, the James Webb Telescope has just shocked the whole space sector. Imagine if galaxies, stars, planets, and everything else in the universe suddenly stopped receding from one another. If the current state of the universe froze, would it collapse into a singularity as it did before the Big Bang, or would it remain roughly the same size it is now? Would everything come to an end? Then let's find out. In December 2021, NASA's James Webb Space Telescope (JWST) was launched as a multipurpose observatory continuing the work of the Hubble Space Telescope. JWST is altering our understanding of the cosmos much like Hubble did. It is assisting us in seeing galaxies that originated right after the Big Bang and determining whether planets circling other stars may support life. Our vision of far-off celestial objects is distorted by the atmosphere, which also blocks some light waves, including infrared wavelengths that are invisible to human sight. Space telescopes with infrared capabilities may study the atmospheres of planets circling other stars, view newborn stars through clouds of gas and dust, and even peek back in time to observe galaxies that were created immediately after the Big Bang. Compared to Hubble, JWST can observe a far wider range of the infrared spectrum and gathers 6 times as much light. It becomes the newest primary space observatory in the world and expands and supplements Hubble's observations. Just 400 million years after the Big Bang, JWST can observe galaxies that are up to 13.4 billion years old. The expansion of the universe has caused galaxies at this distance to move away from us at a rapid rate due to the Doppler effect, which is the same phenomenon that causes an ambulance siren to sound higher-pitched as it gets closer to you and lower-pitched as it passes. This lengthens the wavelength of their light. In other circumstances, Hubble is unable to observe long-wavelength light from objects generated even more recently than the Big Bang because it is displaced far into the infrared. JWST has a mirror that's 8 feet across. Its ability to observe things up to 100 million years after the Big Bang will aid in our understanding of the cosmic origins of the universe. The incredible photos produced by the James Webb Space Telescope have astronomers in awe, yet part of the data already deviates from predictions made by the Big Bang theory. The mature faraway galaxy problem has long been acknowledged by creationists. According to proponents of the Big Bang theory, it took more than 13 billion years for light to travel from the farthest galaxies to Earth. According to the Big Bang theory, we should be able to observe these extremely far-off galaxies not as they are right now, but as they were more than 13 billion years ago. Therefore, these galaxies ought to appear unevolved and immature. Yet preliminary Webb data continues the trend of observations that defy this expectation. We wanted to figure out how Andromeda was moving through space, so in order to do that we measured the location of the Andromeda stars relative to the background galaxies. The first observations made by the James Webb Space Telescope appear to show that large brilliant galaxies had already begun to form within the first 250 million years following the Big Bang. If verified, this would pose a significant challenge to existing cosmological theory. Many of these galaxies seem to be more massive than predicted by the conventional cosmological model, which describes the structure and development of the universe. They are obviously giving proponents of the Big Bang theory some anxiety. The concept of a universe that is no longer growing could be an even bigger issue. At this time, the universe is thought to be 13.8 billion years old. The solar system, in contrast, is only 4.6 billion years old. The mix of matter and energy density in the universe was measured to arrive at this estimate, enabling scientists to calculate how quickly the cosmos had previously grown. With that information, they could go back in time and calculate the exact time the Big Bang occurred. The Big Bang created the cosmos from an infinitely dense and incredibly hot point. An enormous burst of expansion known as inflation occurred when the universe was only about 1034 of a second old, or 1/100th of a billionth of a trillionth of a second in age, during which time space itself expanded faster than the speed of light. From its subatomic beginnings to its present golf ball size, the universe expanded by a factor of at least 90 throughout this time. The work that goes into comprehending the expanding cosmos is a result of both astronomers' first-hand observations and theoretical physics research. The cosmic microwave background, which is the relic radiation from the Big Bang, is one instance where astronomers have not been able to observe gravitational waves directly. After astronomers discovered that the signal detected may be explained by dust in the Milky Way, a preliminary announcement about discovering these waves in 2014 was swiftly retracted. So I pushed this idea one vital step further. You see, he realized that if space is flexible enough to warp, NASA claims that the expansion of the cosmos continued after inflation, albeit more slowly. The universe cooled as it expanded and matter began to form. The universe was bursting with neutrons, protons, electrons, anti-electrons, photons, and neutrinos 1 second after the Big Bang. The light elements were created in the Big Bang nucleosynthesis process, which took place within the first 3 minutes of the universe. The hydrogen isotope deuterium was created as a result of the collision of protons and neutrons. As temperatures dropped, trace amounts of lithium were also produced, and the majority of the deuterium was mixed to create helium. The early cosmos was fundamentally too hot for light to shine for about 380,000 years. Atoms were violently broken up into a dense plasma, an opaque soup of protons, neutrons, and electrons that dispersed light like fog as a result of the intense heat of creation. According to scientists, the early universe had little to no structure, and matter and energy were dispersed almost uniformly everywhere. NASA claims that the huge web-like structure of stars and emptiness that is seen now was created by the gravitational pull of tiny variations in the quantity of stuff at that time. Dense regions drew in more and more matter through gravitational attraction, and as they grew more massive, the more matter they could draw in. As a result, they formed stars, galaxies, and larger structures like clusters, superclusters, filaments, and walls, with great walls made up of thousands of galaxies that were as long as 1 billion light-years. Less dense areas did not develop, turning into voids or areas of apparent emptiness. According to NASA, scientists believe that the cosmos was made almost exclusively of common atoms or baryonic matter until a few decades ago. You realize that our galaxy is part of a local group of galaxies, perhaps 30, and our galaxy and Andromeda are the two biggest galaxies in this local group. The majority of the components that make up the universe, however, appear to exist in forms that are invisible to the human eye according to increasing amounts of recent data. It turns out that only 4.6% of the cosmos is composed of atoms. The rest is divided into two components: dark energy, which is thought to be driving the universe's accelerated expansion, and dark matter, which is likely made up of one or more species of subatomic particles that interact with conventional matter only very weakly. According to NASA, hydrogen makes up approximately 75% of the atoms that we are familiar with, helium makes up approximately 25%, and heavier elements make up only a very small portion of the universe's atoms. In what way will the universe end? This is a question that people have thought about for thousands of years, and now that science has the knowledge and resources to do so, an attempt can be made. Astronomers believe the cosmos would constantly expand and collapse in an unending cycle of cosmic death and rebirth. Until very recently, however, the strongest evidence leads to a distant Armageddon that is even more existentially terrifying than what is described in the Book of Revelation. Long after the destruction of Earth, the universe will continue to drift away until galaxy and star formation stop. Stars will slowly fade away, leaving the night skies completely dark. Black holes will consume all remaining matter until there is nothing left. The remaining signs of heat will eventually vanish. Instead of dying in fire and brimstone, the universe will likely die in heat death. Astronomers call it the Big Freeze. It didn't always seem like the universe would come to this conclusion. Astronomers believe that the Milky Way galaxy was the entirety of the cosmos around a century ago. Our universe appeared to be static, but as Albert Einstein developed his ideas of relativity, he began to observe oddities. His mathematics suggested that the universe was growing or decreasing, therefore Einstein introduced a cosmological constant. It followed from the special theory of relativity that matter and energy are interchangeable, marking a fudge factor to maintain the cosmos in a more enticing steady state. Hubble's 1929 observations indicated that not only was the universe expanding, but that it was doing so at an accelerated pace, laying the groundwork for our current view. The universe's story has not always been so simple. Cosmologists are still trying to untangle some of the mysteries surrounding dark energy and dark matter, which make up a large portion of the cosmos. However, the debate about how the universe is actually evolving may come to a close if scientists can unravel the mysteries of JWST's findings. If the James Webb Space Telescope confirms that massive galaxies existed much earlier than anticipated, it will compel astronomers to reassess their understanding of how galaxies, stars, and even the universe itself evolve. The implications of these discoveries will be enormous, compelling scientists to rethink what they know about the cosmos, pushing us further from the starting point of the Big Bang and suggesting a whole new understanding of cosmic evolution. Just think, if the universe isn't growing as predicted, what are the implications for our own existence? Would we still be here? Would life still exist? Could there be other dimensions, parallel universes, or even entirely different cosmic realities? With the James Webb Space Telescope continuing to reveal more about the universe, the answers may be closer than we think. In this time of uncertainty and discovery, the boundaries of our understanding are constantly being pushed, and who knows what revelations lie ahead.